All right. Why is it doing that? Oh, there it goes. All right, we're good. All right, read focus up here. Quit talking. Today we're going to be working through some algebraic manipulations. We're going to factor, distribute, and conjugate. So we're going through a lot of information today. The homework is a little bit longer than what you're used to. You might finish because this is 5th period, but you might not. Yep. All right, so if you keep talking, you're definitely not going to finish. 0 over 0 is the indeterminate form, which means you cannot do anything with 0 over 0. You cannot say it does not exist. You cannot say it's 0. You cannot say it's 1. This means nothing. It means you are going to have to keep going and do one of these other methods. So I typed up the different ways that we can manipulate limits algebraically. Today we're going to factor, distribute, and do conjugates. You are going to have to recognize when to do what method, because it's not going to say, oh, hey, on this one factor. It's just going to give you the problem. But hopefully if you have a polynomial that's factorable, you'll recognize that you should factor. And for distributing, if you have parentheses that you can multiply stuff out, that's when you distribute. And conjugates are going to have radicals, which are like the square roots. Tomorrow, we are going to talk about complex fractions and squeeze theorem. Obviously, if you see fractions and fractions, that's when you're going to do the complex fraction method. And when you see trig, that's when you're going to do squeeze theorem. So you have all of these different methods for the separate or the different kind of algebraic problems that you're going to have. Now, after we talk about derivatives, I'm going to show you this rule. It's called L'Hopital's rule. I can't show it to you now because you don't know what a derivative is, but L'Hopital's rule works for any indeterminate form. So L'Hopital's rule is kind of nice because anytime you get 0 over 0, you can just use that rule and you don't have to think about a certain method. The hospitals, yes. But since we don't know what derivatives are, we're going to learn all of these other rules that we kind of use a lot of algebra with. If I lose you in these next couple days because your algebra skills maybe aren't the best, it is not the worst thing, all right? Once we talk about L'Hopital's rules, that will kind of cover most of these type questions. Occasionally, though, one of these other methods is easier than L'Hopital's rule. So it just kind of depends, but it's not something that we're going to spend forever on because it's not worth it. All right, so we're going to spend today and tomorrow. We're going to play bingo on Friday. So if you're missing Friday, you're not missing anything. You're just missing bingo. And you'll have a homework quiz on Monday. All right. On example 50, it says the limit as x approaches 0 of x to the 4th minus 5x squared over x squared. And if you were to directly substitute in 0, you would get 0 over 0, which is the indeterminate form and does not tell you anything. So you have to keep going, and we have to do one of these other methods. Well, because this is a polynomial, I'm going to factor. What is the GCF that you can take out of the top? X squared. And when you take out an x squared, what are you left with?
X squared minus 5.
Yes, x squared minus 5. All right. So one thing I do want to mention is, do you see how I rewrote limit? Like you wrote the limit again? You have to keep writing limit until you directly substitute. If you write your work wrong, they will count points off on the AP test. Even if you get the right answer, but your work is wrong. So you have to keep writing limit. What's up?
It's on paper?
Mm-hmm. Like if this was a free response question, you have to keep writing. They're not going to grade your work on the multiple choice. The multiple choice, you can do whatever you want.
It's all on paper.
What, the test?
Yeah.
No, you have some multiple choice and some free response. But like if this was a free response question on the AP test, you have to keep writing limit until you directly substitute. Does that make sense?
Yeah, I think it's a business paper.
It's both.
I don't have a good test for it.
The multiple choice is on computer, so the questions will be on the computer. You'll have scratch paper that you can work on. The FRQ questions will be on the computer, but you will write your work on paper.
Computers, doing math on computers makes me just want to not do it, just like guess.
I know. It's rough, but we'll get through it. But yeah, you'll write your stuff on paper. So, we'll practice it. Okay. So once I have factored out the x squared, what do you notice cancels?
X squared.
The x squareds. And so then you are just left with the limit as x approaches 0 of x squared minus 5. And now I'm ready to directly sub in 0 for x, which gives you 0 squared minus 5. So my answer is negative 5.
Oh, so it's like it'll be easy to tell, like, so that one's a parentheses and the next one's factored.
Yeah.
Period.
All right, so on this next one, when you directly sub into the top, I get negative 3 squared, which is 9, minus 3 minus 6. What's that going to be? 0. When you put negative 3 into the bottom, you get negative 3 minus 3, which is negative 6. So is this the indeterminate form? No. Your answer is just 0 over negative 6, which is 0. So that's why you always have to check direct substitute first. And I've mixed in some direct substitutions in your homework. So you're kind of in your head always thinking, first try to direct sub in, and then try one of these other methods.
But if it's a number over 0, it's undefined, right?
Yeah, we're going to talk about a number over 0 in the next unit.
Okay.
Mm-hmm. So you shouldn't see any of those right now.
Okay.
Yeah.
I just feel like this is the easiest unit.
It depends. I mean,
Like, does it get significantly harder?
not significantly. We just start moving, I think, at a faster pace. Okay, so on this next one, when I directly sub in, I am going to get 0 over 0. And because these are polynomials, I'm going to try to factor. What does the bottom factor out to be?
X plus 5, x minus 5.
Good. And what can I take out of the top so I have something that will cancel?
Negative 1.
Yeah, a negative, which will make that guy x minus 5. So do you see how it's 5 minus x? It's backwards. All right, so to make it unbackwards, we're going to take a negative out and write it as x minus 5 because you're just changing the signs. All right, so now these guys cancel. On the first example, I rewrote my limit. You don't have to rewrite your limit. If you want to go straight into direct substituting to save you that extra step, you can. But when you directly substitute, that is when you don't write the limit anymore. What's left on top?
1.
And what are you plugging in for x?
5.
5. And so what would my answer be? Negative 110. So once you plug a number in for x, that's when you drop the limit. If you're still writing x, you're still writing limit. All right, 51. Does anybody recognize what this top guy is? Difference of cubes. Do you remember the formula for a difference of cubes? A cubed minus b cubed equals? A
squared.
Oh, wait.
A
minus b.
A plus b squared. Oh, I was doing the first one.
Yeah,
A squared
plus a 2ab.
AB
Plus b squared.
b squared.
Same
We were kind of close.
Same opposite always applies.
Yeah.
I have a question about that.
What's up?
If on a fraction, x minus 2 on top, and then 2 minus x on bottom does not cancel.
It'll cancel, but you got to pull a negative out.
Of both of them?
No, just one. All right, so I have seen the sum and the difference of cubes on the AP test before, but once again, it's not really a super big deal, and a lot of times we could use L'Hopital's instead of using the sum and difference of cubes formula, but occasionally it is still a good thing to know. So on this one here, I'm going to rewrite limit because I'm factoring. All right, so what would my A be?
X.
X, and what's my B going to be? 2, because 2 times 2 times 2 is 8.
Oh.
So I'm going to go x minus 2, x squared plus 2x plus 4. And I don't know if I've mentioned, but the goal here is to cancel something. So if you are factoring and something's not canceling, it's either not the indeterminate form or you did something wrong. Because the whole point of manipulating these expressions is to get something to cancel. So here, the x minus 2's are going to cancel. Yep, and then we can directly substitute. So I've got 2 squared plus 2 times 2 plus 4, which I think is going to be 12. All right, can I go over to 53? All right, 53 is your regular trinomials. When you plug in 2, you are still going to get 0 over 0. So it is the indeterminate form. And I'm going to factor. So what two numbers multiply to give me negative 8, but add to give me 2? Positive 4 and negative 2. And then for the bottom, what multiplies to give me negative 2, but adds to give me negative 1? Yep, x minus 2 and x plus 1. Once again, the goal is for something to cancel. Yep, so the x minus 2's. And once you cancel something, that's when you go into direct substitution. So now we're going to plug 2 in, and so you get 2 plus 4 on top, 2 plus 1 on bottom. So 6 over 3, which is just 2.
I don't honestly assume that the factoring seems pretty.
It is. Mhm. Yeah.
Wait, do these just take long because it takes us a long time to do each one? Or
It's just a lot of information.
what? So what are they trying?
Okay, so for the sake of time, do you want me to do a bottoms-up factoring, or do you remember how to do that?
Wait, no, that's pretty okay.
I'll do it quickly, okay? All right, so because there's a number in the front right here, that 3, we have to take that 3, times it by the end, so this is really a negative 6. So when you're thinking of your factors, I want two numbers that are going to multiply to give me negative 6, but add to give me 5. So that's going to be 6 and negative 1. But because you multiplied by 3 in the beginning, we have to remember to go back and divide by 3. And so 6 divided by 3 is 2. And then we're going to bottoms up this other 3 because 1 doesn't divide by 3. So we bottoms up the 3, we put it in front of the x, and so you get 3x minus 1. And then the x plus 2 on the bottom is going to just stay x plus 2, which if you notice will cancel. And once you get that to cancel, you can directly sub in the negative 2 and get 3 times negative 2 minus 1, which is negative 7. All right, so I think I tried to hit most of the factoring methods. I've got the cubes, and I've got a bottoms up and a trinomial, and did I do a difference of squares? I think I did.
Yeah.
Yep. Yeah. So those were kind of all the different in GCF. And so those are all your factoring methods that you may see. All right, so the next method is distributing. And you know you're going to have to distribute when you see parentheses. All right, if you see parentheses, something is going to get distributed. Now on this one, I have a delta x. Don't freak out about the delta x. All right, it's just like another variable. So if I'm going to check to see what this is going to equal, I'm plugging 0 in for all the delta x's. Not the x's, just the delta x, because it says delta x is going to 0. So that's going to give me negative 3x plus 2 plus 3x minus 2 all over 0. And what happens with everything on top? It cancels, and so you get the indeterminate form 0 over 0. All right, so since I got the indeterminate form, I'm going to distribute everything and see if stuff will cancel. All right, so on top, I'm going to distribute negative 3 times x, which is going to be negative 3x. Negative 3 times delta x, which is negative 3 delta x. Is that okay so far? All right, then I have the plus 2. And then I'm going to distribute the negative plus 3x and minus 2. And all over delta x.
Wait, so you can cancel.
So that came from there. And this guy came from that guy. And then the plus 2 just dropped down. All right, so I just multiplied everything out on top. Now, what do you notice will combine?
You cancel the negative 3 and the 2.
Yes. So the negative 3x, the plus 3x, and the plus 2 and the minus 2, all of that is going to end up canceling. And so I'm going to be left with negative 3 delta x on top and delta x on bottom. So what else can I do? Yep, I can cancel the delta x's. Is there anywhere to plug 0 in now? No. What's my answer? Negative 3. So with distributing, you distribute everything and then cancel, and then you should be able to direct substitute. So these methods follow the same patterns every time. So when you're doing your homework, if you feel like you're doing the same problem just with different numbers, that's a good thing. All right, so you're just practicing it until you get those patterns down. Okay, now on this one, let's say you come across this one. This is another, it's going to be the indeterminate form 0 over 0. But let's say you're like, oh, I just don't do well with the delta x's. It just throws me off with the triangle and the x, and then you also have regular x's. You can change that to be a letter if you want. It's not going to change the problem. So if you want to change the delta x to be h, H is the other letter that you will see. I don't know why. You can change it to be any letter. Changing it to an H. Do you want me to keep it as delta x?
Yes.
Okay, I can do that. But if any of you are confused with the delta x, you can change it to be any other letter. Yeah? Do you want me to make it y? Keep it as delta x?
Yeah.
Okay. Delta x it is.
Wait, are we going to have to do the long
Uh-huh.
thing? Like the,
Foiling.
that one, yeah.
So x plus delta x squared, we are going to have to FOIL that out.
Plus delta x times x. Like, would you do delta x then parentheses x?
I normally write the x first, so it would be x delta x.
Alright, so at the end of this equation, are we just going to drop down the minus x to the second power?
Yes. So yeah, the delta x is going to stay on the bottom. The minus x squared at the very end is just going to hang out there. So we just need to FOIL out that x plus delta x squared. All right, so x times x is x squared. X times delta x is kind of weird, but the way it's written is x delta x. All right, it's not being squared because they're two different variables. You just write x and then delta x next to it.
Shiloh Green, please come to the office. Shiloh Green to the office.
Then you have another one of those guys. So delta x times x is x delta x. And then delta x times delta x is going to be delta x squared. All right, so after you multiply everything out, you should be able to cancel. So what are you noticing that cancels?
Squared.
Yes, the x squareds.
And then you can come.
Yep, we can combine these guys and make it 2x delta x plus delta x squared, and then my x squareds went away.
And then you can take one of the.
Yep, you can take a delta x out of everything. So every single term, you have to take a delta x out. So I'm going to rewrite it just so you can see. So I have 2x plus delta x. And now we're ready to direct substitute. And we are plugging 0 in to the delta x spot. Nothing can get plugged into the x spot because we don't know what x is. All we know is that delta x is turning into 0.
It would just be 2x plus 2x.
Yep. So your answer is going to be 2x. Okay. Distributing, is that kind of okay? What's up?
Since it's still 2x, do we have to put the limb by it?
Oh, good question. No, because we subbed in for the delta x.
Okay.
Yes. Okay, the last thing that we're going to do today are conjugates. So conjugates are where you're going to have the square root. So if you see square roots, your brain should be thinking conjugates. Once again, this is still where you're going to get the 0 over 0 indeterminate form. So when you plug in 0 here, you get square root of 1 minus 1, which is 0 over 0. So you are still getting 0 over 0. I'm just going to make a note that this is still the indeterminate form, which is why I'm using this method. All right, so I am going to multiply by the conjugate on top, which is the exact same thing. But instead of this minus sign right here, I'm going to turn it into a plus sign. And whatever you do to the top, you do to the bottom. All right, make a note to yourself that you are only multiplying the conjugates. You do not multiply the other, like in this case, the bottom. We're not going to multiply the bottom out. You just multiply out the conjugate. And the conjugates, they could be on top or bottom. You'll see them both ways on your homework. So we're only going to do the whole foiling to the conjugate side of the fraction. The other side, we're just going to rewrite. All right, so I've got the limit as x approaches 0. The bottom is going to stay x square root of x plus 1 plus 1. So this bottom right here is going to stay that guy. On the top, we're going to have to multiply this out. Because this is conjugates, what do I know is going to happen with the middle?
You're gonna cancel.
Yes, they'll cancel. So we don't worry about the middle.
Blake Hodgman and Peyton Reed.
What, we're just going to say their names? Okay, I guess we are. They're going to come back on in a second. So because these are conjugates, the middles are going to cancel. And so we just have to multiply the first guys and the last guys. So what happens when you take the square root of x plus 1 times the square root of x plus 1? X plus 1. And what is negative 1 times 1? Negative 1. And just like all of the other methods, once you multiply by the conjugate, stuff should end up canceling. So what do you notice cancels? The 1s and the x's. And so once you cancel that stuff out, you can directly substitute in. You're going to have an understood 1 on top. And then you will have 0 plus 1 in the square root plus 1, which will end up just being 2. So your answer is 1/2. And it will follow that same kind of pattern. Okay, let's drop down to, I'm going to do 60. All right, when you plug 4 in, you're going to get the indeterminate form 0 over 0. So we are going to multiply by the conjugate. So what am I going to multiply by?
You're gonna multiply 5x square root plus 3.
Plus 3, yep. So square root of x plus 5 and then plus 3. So instead of this minus sign, that's going to be a plus sign. Notice the sign inside the square root just stays normal. Yeah, you're only changing that sign.
And then to the bottom.
And then you got to do it to the bottom as well. Okay, so like I said, on the bottom, because that's not where my conjugates are, the bottom we're just going to rewrite. The top is the only thing I multiply out. So I do not have to FOIL out the x minus 4 with this stuff right here. That's crazy. We're not doing that. Don't do that. You'll start going on all kinds of crazy things. So we're just going to rewrite the bottom because those aren't conjugates. And the conjugates on top, we get to multiply. So the square root of x plus 5 times the square root of x plus 5. X plus 5. And then negative 3 times 3.
Oh wait, I'm sorry.
Negative 9. Because 3 times 3 is 9.
Yeah, I got distracted.
So it becomes -4.
Right. So this guy here doesn't cancel yet, but you can combine the 5 and the -9 to make that. And you don't have to write this step. Like, you could just go ahead and cancel. But just so you can see it in your notes where I'm getting it from. 5 minus 9 becomes -4, and then those guys would cancel.
So does that still leave a 1 on the top?
Yes. Yes. So the 1 is still on top. We can plug the 4 in for the x right here. So 4 plus 5 is 9. Square root of 9 is 3. And so on the bottom, 3 plus 3 is 1/6. I don't know. I don't know what this art room does over here, but sometimes it gets crazy.
It sounds like you're wondering.
Okay, how are y'all feeling about the conjugates? Do you need to see any other examples?
No.
Huh?
Oh my.
Okay.
It's the opposite.
Yeah. Oh, because you conjugate in Spanish?
Yeah.
Yeah, it's different.
That's what I remembered.
Yeah, different in math. They follow the same pattern. So I want to give you a chance to kind of work on it yourself. So you can work on your homework. Like I said, you might not finish the homework. Well, yeah, you can cross those off. We won't do these guys. If you're interested in seeing them, I posted them in Schoology. But you do have a homework quiz tomorrow over factoring, distributing, and conjugates. So make sure when you're looking at your homework, you at least hit up one of those examples each. There's also direct substitution mixed in with your homework. So not every one needs a special method. Sometimes you're just plug and chugging. Okay, so you kind of have to watch out for those. And then tomorrow, we are going to be doing fractions and squeeze theorem. And then on Friday, we'll play bingo and kind of practice all the different methods. And I will have opportunities for you to, I'll make some kind of baked good for Friday. And yeah, if you win. I know, I'm sorry. I know.
Oh yeah, all of them are gonna be gone.
Yeah, y'all are all gonna be gone. But you don't have to make anything up
No,
either.
but it's bingo. You're still kind of low.
Wait, but we're gonna have to learn the lesson for tomorrow.
Yeah. Which I can come teach you right now if you want me to.